Hey class, so we're back again, and now we're looking at example 2 from chapter 8.2. So this is going to be connecting the slope of a line segment to a rate. And you should remember this from grade 10, how slopes represent rates. So the problem we're given says describe a scenario that could be represented by this graph and compare the rates shown and discuss why the rates may have changed. So what I'm going to say is that imagine Richardson finds out that down at the Fish and Fever shop on Agricola in Halifax that there's an immense sale on fly rods, and he decides, oh my God, I've got to go. When he gets out to the parking lot, he finds out that his tires are flat. So he decides, I'm going to run right to the fishing shop. I'm not going to waste any time. So this could actually represent, say, his distance from CPA. So say CPA is here. So he's 0 minutes from CPA at the start, or 0 distance from CPA at the start as well. And what happens is he starts out heading towards Fishing Fever. So remember that slope is calculated by rise over run. So if we look at the rise in this scenario, it looks like we've gone 2 kilometers, and then we've ran, it looks like 30 minutes. So if I wanted to calculate slope 1, so I'm going to denote this as M1. I actually have my rise is 2 over my run is 30. I've left my units out of it. I'm going to simplify this first to 1/15th, and that is 1 kilometer for every 15 minutes, which kind of seems accurate for Richardson. He's a little bit out of shape. So this tells me that he started running at 1 kilometer for every 15 minutes. Okay, we could express this in decimal form, but fraction forms are good too. You'll notice what happened here is he actually got out of breath, and all of a sudden he had to stop. Now how do I know he stopped? Because there is no change in distance. So for 10 minutes, 10-minute gap here, it looks like he took a break. So what is his speed at that point? What is his slope at that point? Well, there's no change, so there's no rise. So that is a rise of 0 over a run of 10. He actually traveled at 0 kilometers per minute. So he took a little 10-minute break. After that 10-minute break, he must have felt really good, because you'll notice that looking at the rise here, he's gone from 2 all the way up to 5. So that's a rise of 3 kilometers. And it looks like a run of exactly 20 minutes here. So there's a gap you can see from 40 up to 60 would be a 20-minute run. So this would have been slope on segment 2. Here's our slope on segment 3. So again, a rise of 3, a run of 20. That's not really going to simplify, but you'll notice that it is definitely faster than his first rate. So we're going to say 3 kilometers per 20 minutes. And again, we could express that as a decimal. In the end, he actually buys the rod, and he must buy the rod instantaneous because there's no change in time. And then he actually starts to bolt it back to CPA to get his car. And you'll notice here that he actually must have been chased by a polar bear or something like that, because he was running. He has a rise change from 5 kilometers down to 0. So that's a net change of 5 kilometers. And he did that in approximately 5 minutes. So in that last leg of the trip, again, he must have been really, really running from something. He traveled 5 kilometers net change in only 5 minutes. So what was he doing? He was actually running 1 kilometer per minute, which is truly what I do right now. Not even close. Anyway, so that's how you can connect the slope of a line slope of a line segment to a rate. One thing you should be able to do is recognize, okay, I was traveling slower in this segment than I was in this segment, and this is the fastest segment.